My name's Amos Winter. I'm a PhD candidate in mechanical engineering, and kind of a big project that I do is something called Mobility Lab. It's a spin-off of the D-Lab program here that's focused on international development, largely technology for the developing world. And what MLab focuses on is mobility technology, so for people with disabilities. MLab is a physical place, it's a shop, we can prototype stuff, make stuff. It's also an organization under which students can do theses and UROPs and publish papers and have that affiliation. We work on a variety of mobility-related projects. Right now, with the way students work on projects usually is most of them got introduced to MLab through the class that I teach called Wheelchair Design in Developing Countries. MLab started because a lot of students from that class wanted to continue projects past one semester as theses and UROPs. And kind of the biggest project in MLab right now is something called the Leverage Freedom Chair, which is a off-road, go-anywhere wheelchair that's lever-powered, and when you get indoors you can take the levers off. It's a regular wheelchair. We use the acronym LFC. We did a first trial in East Africa from August till January this year. And we had 6 people, 3 guys, 3 women, all different ages, different disabilities, different local terrains that they ride on. And they tested the chair for 4 months, and then we went back in January and did a bunch of surveys to see how they liked it, what they thought, and what they didn't like about it too. And then also did some quantitative performance testing to compare the performance of our chair versus their normal wheelchair. And so through that testing, we saw that our chair is good at what it's intended to be good at. It's very good off-road, especially for people who need the seating, cushioning, postural support of a normal wheelchair, but want to have more mobility. Very, very capable for them. You know, they're able to go farther, more difficult terrains. Like, really big advantages stood out in their survey data and in their performance data. But the shortcomings of the chair are that it was too wide, and so it was hard to use indoors. And most of the day, you're not commuting. You know, you may commute for a couple hours a day, but you know, the other 12 to 14 that you're awake, you're just kind of hanging around your house or your job or whatever. So we saw that we needed to make our chair a better wheelchair when the levers are off. Another complaint was that the seat was too high and the chair felt too tippy backwards. So we've changed that, dropped the seat. We've actually played with the wheel position a little bit, set it back a little bit. So it's much more stable now. And another feature we incorporated was a pad, and this is kind of unique to our chair. It's a pad that hits you behind right behind the shoulder blades, and it acts like a bench press bench, right? So when you push on the levers, you push your back right into that bench, right? And you don't really feel that pad when you're just sitting normally in the chair because it has a regular cloth seat back, sling seat. But when you push back and your shoulders tip back a little bit, you do feel that pad and it really supports you. So that's a really, really nice feature. We've gotten great feedback on that in this new prototype. And the reason we did that is because if you have a spinal injury, a lot of times you lose the control of your abdominal muscles. So when you're pushing on these levers, you know, usually you tighten your abs so you can keep your torso vertical. But if you don't have ab muscles, you tend to like go back over the seat like that. So that's effective. So, you know, we did that trial in Africa, and first I thought of the idea, the whole idea behind the chair, the way it works, is that you've got these long, I don't know if you've probably seen it, right? You've got these long levers, and to effectively change gear, all you do is grab the levers at different positions. So if you need a lot of torque and to go through mud or sand, you know, high resistance terrain, you just grab high, and you get that long lever arm, produce a lot of torque to the wheel. And as you slide your hands down, every push you do, you go through a larger angle, and so you actually create a faster rotational velocity. So you're spinning the wheels faster than you could just grabbing the handrail and pushing them. And so the whole idea behind that is that all the mechanical complexity is in the person. You know, our bodies are very well built to do complex motions like, you know, grab a lever, let go, slide down, grab it, you know.
Yeah.
That's a very complex mechanical motion. So by having all the mechanical complexity in the person, the drivetrain itself, the machine, can be very simple, and it is just a lever, some, you know, bicycle chain. So I thought of that lever idea, shifting hands on a lever to change mechanical advantage, in the fall of '07. And then I started the project as an independent study. We can do a graduate class. It's an independent study with Dan Fry in our department through the spring semester, and developed the idea, did some research, looked at what power you can get out of the upper body at your peak efficiency, looked at how much force output you can get, and then looked at what terrains we wanted to travel on, and used that to match what gear train we should use, what gear ratio, what lever size, all of that. So the idea is that you can operate at peak efficiency on common terrains like pavement, like slight grades of hills, gravel, and then also produce enough torque at the wheel to go through really rough terrains like steep hills, mud and sand. So I did all that analysis, and we won the ideas competition with this, and it was pretty much just a sketch on paper. We had made a drivetrain mock-up, but it's actually much different than what we use now. And so after winning the ideas competition, we went through a couple prototypes, and we actually took one to Vietnam and one to Tanzania and Kenya. We built 3, and they were horrible. Like, the layout was totally different. It was backwards from a normal wheelchair. We had the big wheels in front and the small wheel in back. And the idea was that you could use the big wheels to kind of like climb up obstacles, and you wouldn't tip over backwards and stuff. You know, that sounds cool, you know, but it doesn't really work well in practice, because when you climb a steep hill, you put more weight on that small back wheel, it tends to sink in. Another problem is when you're trying to go up a hill, you're always turning to, like, you know, your back swings around, so you face uphill, so it's very hard to climb uphill. And then your uphill wheel loses traction because you're, you know, putting a lot of weight on your downhill wheel. So it's a mess. And then going downhill is even more dangerous, because the chair always wants to swing around to put the small wheel in front, and that's because there's more drag on the front wheel than the rear wheel. So yeah, in practice that was terrible. And what was good is we went abroad and tested this with some people, with our partners, and they were like, "This is terrible. You know, this is not going to work at all." So we came back and kind of went back to the drawing board, and Mario Bellini, who I've been working with for years, he had a great insight saying, you know, let's scrap this idea of flipping the wheels around and all that. You know, it's too complicated. Let's just take a regular wheelchair platform, put the lever drive on it somehow, and, you know, use that and take the levers off, and then you have a normal wheelchair. You don't have to flip the seat around or do anything funky. It's just a normal wheelchair, add levers, you get an LFC. That was a really good insight. So that was the approach we started taking, and there was quite a bit of experimentation time during that. We're just figuring out where do we put the levers, like, you know, how do we constrain them so they're rigid enough, because the highest forces in the chair are actually in the chain. You know, if you're pushing with, you know, a couple 100 pounds in each hand up here, you know, you can be producing 200-300 pounds in each chain, you know, which will warp the frames. Like, we have to be kind of careful how we stiffen our frames. So I had to work all that out. We did some testing, made an initial prototype that worked great, actually. We wrote that quite a bit, did some testing with that, comparative testing of our chair versus other products available, saw that there's big advantages. And then that prototype led into the one we trialed in East Africa. And the East African one was a much more refined chair, had a full cushion, had the correct posture, like had parking brakes. Like it was much closer to what a real product would be. That's the one you've probably seen in the pictures.
Yeah.
So that was kind of a big leap. You know, the devil's in the details. And so now our next one is going to be much lighter, much narrower, smaller, lower. You know, it's got a lot of, like, I guess they're design tweaks. The general idea behind the chair hasn't changed, but, you know, again, the devil's in the details, just making it, you know, a really good product. So yeah, it's progressing along really well, and I think our next chair is going to be awesome.